Good evening, Kavita ma'am, Miss Najia, Mr.
Good
Biju S.
evening,
Pillai.
sir.
Good evening, sir. Good evening,
Kavita ma'am,
Kavita
can
ma'am.
you hear me?
Yes, sir. Yes, sir. Good evening, everyone.
Good evening. Biju sir, over to you. Let's
Yeah,
introduce
yeah.
our moderator.
Ms. Najia Amin, an educator with a decade of experience, specializes not only in academic development but also in psychology for holistic personal growth. She is the author of a pioneering phonics series, uniquely color-coded for effective learning. Hearty welcome to Extra Mile Education and Training. Please proceed. The stage is yours.
Good evening, everyone.
Good
Good
evening,
evening, ma'am.
ma'am.
Yes, good evening, everyone, and warm greetings from all of us at Extra Mile Education and Training. Extra Mile was established by Dr. Abdul Salam, the founder of BTAG. It is a dynamic training platform dedicated to empowering educators nationwide. We offer both online and on-site training tailored to your needs. With our growing network of resource persons and subject matter experts, Extra Mile extends to reach to educators across the Indian and Gulf countries, continually striving to achieve educational excellence. I extend a warm welcome to our program director, Dr. Abdul Salam, respected Mr. Biju S. Pillai, and a resource person for the day, Ms. Kavita Kadam, and all our dear participants who have joined us this evening. Welcome. It is indeed a pleasure to have each one of you as an integral part of this webinar as we go about exploring how art can be integrated into our chemistry lessons. It is a great feeling to be present here today, and I extend my humble gratitude to Dr. Abdul Salam for giving me this opportunity. Thank you, sir. The objective of today's session is to understand how art can be integrated into chemistry lessons, which will help us cater to diverse learning styles, enhance retention, and foster creative or critical thinking skills among our students. Before we begin with today's sessions, there are a few things I'd like to remind you about. Switching on your device camera is optional. However, for any query in midst of the session, it should be conveyed through the chat box. In order to have an interactive session, you may note down all your queries and Ms. Kavita will be happy to dispel your doubts at the end. Please click the raise hand button and wait for your name to be called out when the forum is open for discussion. The participants will have an opportunity to receive a certificate only after filling the feedback and certificate form, the link for which will be shared at the end of the session. Kindly stay connected. Moving on, I am now pleased to introduce our program director, Dr. Abdul Salam. Sir is a renowned CBSE person and a master trainer. He has been associated with National Accreditation Board for Education and Training under the Government of India as an assessor. He is the founder and CEO of Extra Mile Education and Training and the Bharat Transformers Academic Group, known as BTAG. Sir, we are honored to have you with us this evening. Kindly invite you to deliver the welcome address.
Thank you. Good evening, everybody. Thank you, Najia ma'am. Respected resource person, Kavita Kadam ma'am, Mr. Biju S. Pillai, and all educators who have joined. Very happy to see science teachers joining together to take away a lot of things which have been, in pipeline for many days and have, come to materialize today. And at the outset, on behalf of everybody, I would like to thank Kavita ma'am for her wonderful effort. She has prepared a lot of things for you. A huge effort has gone into the preparation, and we are pretty sure that you will take away a lot of things and your classes will be very much enriching and interesting. So let's, without any further delay, let's listen to Kavita ma'am and enjoy the session. Thank you. Over to the moderator. Thank you.
Thank you, sir. Participants, allow me to introduce you to Mr. Biju S. Pillai, a highly esteemed educator with extensive experience in the field of education, having held principal positions in different prestigious schools. Sir, we are honored to have your gracious presence amidst us. I request Biju sir to address the gathering.
Thank you, Ms. Najia Amin. Respected Program Director, Dr. Abdul Salam, sir. Today's resource person, Ms. Kavita Kadam, and all other educators around the globe. Wonderful evening. So, as very intelligently how the CBSE has brought art integration in all the respective subjects, and for the couple of years we have seen how teachers have integrated it in a proper way, and in a very successful manner. This art integration is being carried out in all the respective recognized CBSE schools. So let us see today, this evening, how chemistry is being brought by Kavita ma'am. This art integration in every classes, how it is intelligently being utilized. So let us hear to her voice and take more knowledge after this evening. So I welcome all chemistry teachers and all respected science teachers to this platform. Back to Najia ma'am. Thank you, ma'am.
Thank you, sir. It is my pleasure to now introduce you all to our esteemed resource person, Ms. Kavita Kadam. She has an experience in the field of education over 24 plus years. She has done her MSc in organic chemistry. She has worked in various capacities of state board and CBSE schools, handled senior secondary classes in state board for 3 years, and worked as an evaluator during board assessments. She has worked in DPS, handled science club activities and exhibitions. She has worked in Army Public School, Maharashtra, for around 20 years as a HOD of science in chemistry, the vice principal, educationist, and subject expert during interviews. She has been the head examiner during CBSE spot evaluation and PGT chemistry. She has received an appreciation letter from the Ministry of HRD for excellent board results, and also received an appreciation certificate from the school management for excellent results and her students scoring centum in chemistry. Congratulations for that, ma'am.
Thank you so much.
And she has worked as a CBSE and Faculty Development Research Center resource person in Pune. She is presently working as a principal in a CBSE school, APS Khadakwasla, Pune. Ma'am, it is wonderful to be here with you and an absolute honor for me to be working with you this evening. On behalf of everyone present, I welcome and request you to take over the proceedings for the evening. Welcome, ma'am.
Thank you so much. Thank you so much, ma'am. And I would like to, first of all, thank the organizer of this show, Dr. Abdul Salam, Dr. Biju Pillai, and ma'am for such a lovely introduction. It's a privilege for me to be here amongst all the educators, and I'm sure we all will share each other's knowledge. So without wasting much time, I would just like to share my screen, and just let me know if it is visible to you. All right. So I think my screen is visible.
Yes, now it is, ma'am. Yes.
Yes.
Okay. So, friends, let's begin with the topic of today, art integrated learning in chemistry. So what is it all about? We will be seeing, as you can see, there's a lovely girl standing here in a lab with her different cartoon structures drawn over there. from where we got this idea of art integration. Takes its basis from NEP 2020, page 12, which talks about art integration is a cross-curricular pedagogical approach that utilizes various aspects and forms of art and culture as the basis for learning across subjects. As a part of the thrust on experiential learning, art-integrated education will be embedded in classroom transactions, not only for creating joyful classrooms, but also for imbibing the Indian ethos through integration of Indian art and culture in the teaching and learning process at every level. This art-integrated approach will strengthen the linkages between education and culture. So if you just look at this paragraph, friends, you will understand that the ultimate aim of introducing art integration is to create joyful classrooms. Also, we are going to strengthen the linkage between education and culture. Before we begin, we'll just have a look at these two images which are in front of you. And I would like to take your views on these two images. What do you feel about these two images? You can just express your opinions in the chats, like how you feel, which image is better and why. Yes, that's right. Very nice. So, image B, absolutely. Yes, Surya ma'am. Yes, absolutely. Absolutely. Interactive, better, child-centered. Fantastic. So I'm getting your views. Excellent. So thank you so much for learning by doing student-centric. Of course, we can see that in the image B, the children are actively involved. They are interactive classrooms. Teacher is oriented towards students, right? In image A, we see that the children really is finding the lecture very boring. They are just, about to sleep. All right. Now, when we look at this image, this is today's scenario, my dear friends. I'm sure you all will agree with this, right? So what do we understand in this picture? This picture. Yes. Yes. So here we can see there's a lot of burden on students today. They're studying a science student, for example, if we take, there's a burden of all these subjects, such high cognitive they have taken. There's so much pressurized. That's right. Students are afraid of exams. They're afraid of results, correlation subjects. Exactly. There's so much of confusion. Right, Rashmi? I agree with you. So, friends, with that, we are now introducing art in our curriculum today, where we can use it for teaching, we can use it for evaluation, we can use it as one of the learning methodologies, right? Now, in front of you, there's a jar over there, and if somebody can tell me what is this super absorbent used diapers, this SPA standing for? Yes. It stands for sodium polyacrylate. It's a super absorbent material which is used in diapers. Now, what is art integration? I'll just quickly take it. There are various forms of art. Basically, we'll be talking about two forms of art which are common. The first form of art is visual art, and the second one is performing art. When we talk about visual art, it can be various types of art forms like painting, we can have drawing, coloring, rangoli art, we can have sculpture, modeling, print making, photography, collage making, and filmmaking. Similarly, when I talk about the performing arts, it can be dance, theater, drama, skit, role play, and music. According to CBC, we can have lots of suggested activities in art integration, as we have just now discussed. These are the various activities which we can have. we all can have role play. We can have arts exhibition. We can have video filmmaking. We can have paper quilling, jewelry making, design through Photoshops. We can have photography. We can have creating an art reservoir using waste material. We can have dance performance, sculpture, sketching, visit historical places, monuments, exactly, clay modeling. We can have slideshows. Yes, Anuradha ma'am, you're absolutely right. So let's begin with the first thing is basic chemical reactions. So how can we go about teaching basic chemical reactions to young students right from class 7th, 8th, I think, start teaching them about the reaction and use these kind of pebbles or stones to teach them the concept of molecules. We can use stones, like for example, in this we can use CH4, we have used methane and oxidation of methane is happening and we're getting carbon dioxide and water. So instead of pebbles or stones, we can use something different also. Then students can also be asked to craft their molecular models because lots of activities can be done by using scissors, papers, and thermocol balls, and you can make models of this form. I'm sure every one of us have got these activities done by students. So how many of you have done these activities? Can I just see your hands raised? These art and craft activities of making models, please. Exactly, simulations and animations. Very nice, Elizabeth, ma'am. Yes, that's right. So thank you so much. Yes, absolutely. Then we have innovative drawings. Yeah, that's right, Rashmi. So we can use innovative drawing methods to show the various models of, atoms. Absolutely, ma'am. We are introducing the concept of electrons, protons, neutrons, and the subatomic particles. Yes, we can use innovative models, like now here we are using paper plates, crockery we are using, and here we are depicting the model of atoms. So you can leave the children to draw on their own. Wherever they want to draw, they can use this concept. Some of the children can even draw 3D models, like these two boys are holding one of the models, right? So we can have such innovations. Yes. Good evening. Have colorful charts. Now, this starts from lower classes. We can ask the children to draw various kinds of the electrons, and neutrons. We can also make models of this pattern. This is for class 9. Now here, see, you can see on the left side, Bohr's atomic model. Yeah, I'll just, you can see here Bohr's atomic model of nitrogen atom. So how beautifully this concept has been shown. Also, we can see here the 3D model on the right side. So as you can see, now I think Rutherford's model starts right from class 9th. So we can also ask the students to draw the diagrams of Rutherford's model, wherein we are trying to show the alpha foil gold scattering experiment, or we can have them, we can ask them to make the models of this with the help of papers. Now talking about, talking about global warming. Now this concept which starts from lower classes, we can use it. You can see a beautiful model using cotton and cardboards and various other material has been made. And also we can see on the right hand side, hole on the ozone layer is shown over here, right? So this, we can connect it with class 12th also, where in the chapter haloalkenes and haloarenes, we are talking about the depletion of ozone layer by the use of chlorofluorocarbons. So, we can connect this topic very well with the higher class students also. Coming to the next, we have the DNA model, which we can show it in biology also. We can also show it in chemistry, especially in the chapter biomolecules when we talk about where we are showing how these two strands of DNA are intertwined with each other. You can use the art method. Now here on the right side, the student has beautifully made a design on the meti cloth of cross stitch she has used, and she has written stop copying me. So here we're talking about exactly, Prabha ma'am, I agree with you. Teachers must take initiative to make models. Absolutely, ma'am. Now, this really I appreciate, and this student right now, she's in Surabhi class 12th A. She's a beautiful work. Now, this is another method of art integration of teaching love towards the structures of organic compounds. Even when I was a student, I used to draw. I was not knowing how to draw rangoli actually. So I used to draw benzene rings and to show various patterns. So in the same way, students can also draw the various molecules of organic compounds or anything which they like. Now here we are connecting exactly, and Anuradha ma'am, benzene compounds can be shown. Now here what we are doing is we are connecting the culture with the subject, that is chemistry. Now, the next is from class 9th. When we start teaching about the concept of matter, we can ask them to get the objects which are around them, like matter, for example. We have asked them to paste the pictures of solids, liquids, and gases. Right, Prabha ma'am? I agree with you. Yes. So to study the properties of states of matter using two-dimensional activity. So here, such a beautiful work you can see. Here the child has stuck a chair, which is a three-dimensional object, talks about solid, talks about the water in the classroom. They are bringing water bottles. They talk about the air balloons, which they are using for their birthdays. So we are connecting them with the everyday life, learning by doing, using your senses. Then we can also use craft work to show them the parts of white light, which they can do it by drawing diagrams, or they can use craft work like in this, for example, in this slide, you can see that there is a, what you say, thread work has been done. And how the light is getting diffracted has been shown. So, you can use this pattern for explaining physics. You can explain it for showing the various parts of spectrum in the class 11th standard chemistry. And beautifully, the children get involved in that. Then this is a beautiful pattern which I came across, dispersion. Exactly, Sadaya Shiva ma'am, that's absolutely correct. So dispersion can be shown. Now this beautiful picture which I saw in the internet, right, Rashmi ma'am, electromagnetic spectrum. Carbon and its compounds. Now you're introducing carbon and its compounds, and I think in class 10th you're started. So the concept of homologous series can be easily shown by drawing such, pictures like the pattern. So we have H4, then we have C2H6, methane, propane. So there's a gap of H2. So how it is getting added up and we are getting the homologous series getting created. Same way you introduce the various elements for like for example, for the lower classes, you can use this method. The children can at least learn the first 12 elements. Like we have started here from hydrogen till magnesium we have reached. So it's really beautiful, and children love such things. And you can decorate your laboratories with such beautiful, masterpieces which the children have created. Now we can have some innovative cards and strips. For example, we can have like these patterns, like we can put it in the magazine also, like oxygen, the most sociable element. It interacts everything apart from inert gases. Okay, so I hope you're able to see the, yeah, so you can just have a look at this, like mother, like you can see on the Mother's Day, we can show this, uh, right? We can show this, and we can show that molybdenum, then thorium, then erbium. These three elements we are combining together to give the concept of mother. You can have creativity cards like this, science brains at work. Like think like a proton, always positive. Okay, fine. So I think there's some network issue over here. Right. So, okay, fine. Let me just go ahead. So now here we can have balancing chemical equations, which we can use a three-dimensional activity used for presenting balanced chemical equation. Children can be shown like two magnesiums, or one molecule we get molecules of magnesium oxide. sodium atoms we are combining with 2 water molecules, and we're getting 2 different products, sodium hydroxide and hydrogen gas. You can also use this kind of to make aprons or lab coats. They can beautifully decorate their lab coats with different designs. Like for example, here we are trying to show, like we are using helium as a design on the left hand side and aluminium on the right hand side. So anything creative can be done. How reactions occur. This can be best depicted by using role plays of this type. Like I can just show you one of the role plays which our students have done. So I'm sure you'll be able to see this.
Good morning. Today we will explore the fascinating process of the reaction between carbon and oxygen. Initially, at room temperature,
Yes, Anuradha.
oxygen level bond remains intact, preventing any reaction from occurring. However, when heat is introduced, it provides necessary energy for the oxygen level bond to break down, leading to the formation of 2 oxygen atoms.
In this exciting state, carbon equally bonds
So
with oxygen,
here you can see
resulting in
that
the
how
formation of carbon
we are
dioxide.
using these students for depicting atoms, 2 oxygen atoms, and we can have we are seeing that making 4 bonds, 1, 2, 3, 4. So this way the children get involved and they understand the real concept of how the molecules are formed.
Heat plays a crucial role in initiating and driving this chemical reaction between carbon and oxygen atoms. Now my question is, how many bonds are there in the molecule of carbon dioxide? What is the valency of carbon?
So here we could see that by a small experiment role play, children are learning the concept of bonding. They're also learning the concept of what is the meaning of valency, you know. So it's really very interesting. Let's come to a topic which is from, I've taken it from class 12. We can start this concept of depression freezing point. We these students to make a video. This can be done at home or it can also be done in the laboratory, making an ice cream which students love so much. So here video what we can show activities that ice cubes. We take ice cream mix and then we start we keep this ice cream mix in the ice cubes and give it some time to freeze. So we will find that it takes a lot of time for the ice cream to freeze. Whereas in second experimental setup, we are using different concept, adding salt in the water, that means in the ice cubes, and then we are putting this ice cream mix. So in the second case, there will be a quick freeze of the ice cream. So can you just tell me why the ice cream is made very fast when we add salt to the ice cubes? Yeah. So let just write your answers in the chat box and why does the the ice cream form so quickly when we add salt to the ice? Different in the freezing point occurs. Absolutely. Absolutely, Shelja ma'am. Neetu ma'am. Exactly. So this is the concept which we can teach to the children. And where has the heat gone now? What is the ice doing? The ice is basically going to melt. And that temperature it is going to take from the cream mix and it starts freezing. Absolutely. Thank you so much, Asha ma'am. Yes. Now this is this is the way I teach exactly. Darshana ma'am, yes. I teach concept of chirality. What is chiral compound? What is a chiral compound? So we can teach the students the concept of chiral, which means asymmetry, and achiral means symmetry. So we can word that can be talked about. Draw the of the hand. So my hands, the left
Miss Kavita, sorry to interrupt. Miss Kavita, your voice is
Yes.
breaking and your visual is also not moving. So you have a very poor bandwidth. So you can close your visual video.
Yes, I'll just wait. I'll just...
There's a low bandwidth. Yeah, correct. Now the video is fine.
Ma'am, you're on mute. No, ma'am, you're on mute. I think you're saying something.
We cannot hear you. We are co-host only, so you can unmute and you try again.
I've I think unmuted myself now.
Yeah, it's fine.
Yeah. Okay, so sorry for that. Now I'll just
Now the video is fine. Now please see the PPT. That's
I'll just go to the slide which I was on.
yes, please.
Okay, so sorry for that. So I'm sure we have covered up this depression in the freezing point, how we can use this experiment to teach children the concept of depression freezing point. I was talking about the chirality.
Excuse me, are you
I will
sharing the
share my...
PPT? Yeah, please share your PPT.
See that, yeah.
Kavita, ma'am, one suggestion is you can switch off your video. So at least the audio
Yes.
will be clear and you can share screen.
Yes, ma'am. Just a minute. I am actually not able to see that. You just come.
No problem, ma'am.
Yes. Zoom. I'm just a minute. I'll just be able to see that Zoom screen. Sedu?
Madam, there is an update from Zoom. Now you will have a dual screen. So you can see on top, meeting, my meetings and my screen. You can select your screen on top.
Got it, sir. I'm going to share my screen. Share sound.
Yes. Yeah, right.
Okay, fine. So what we were discussing is these concepts of chirality we can teach the children by drawing the various types of figures. Like we have drawn the pair of slippers over here. So these are chiral objects. What is a chiral object now? It's going to be a non-superimposable mirror image. Similarly, when we start teaching set of packing in solids, now what is the very good efficient packing? As we know, the packing in which there is maximum space is occupied and minimum space is empty. So here in this, we are using beads to show the concept of two-dimensional packing. and three-dimensional packing. For this, we can also use or laddus to explain the concept of packing. Then we have this experiment of using chromatography. So what is chromatography? Basically, what is chromatography? Can someone just help me in that? Writing in color. Elizabeth, ma'am, right? Rashmi, ma'am, separation technique. It's FIBA, right? Excellent. So chromatography, the word has come from separation of colors. So we are using this in class 11th for, showing them a paper chromatography. So designs of this type can be made, various kinds of flowers, as you can see, the children have drawn, and they will develop the love towards the subject. Then osmosis is one of the commonest experiments which we do. Like here, we can ask the students to do this kind of experiment. Right, ma'am. Usha, ma'am, I agree with you. We have taken a potato. We have made a hollow cavity in that, and inside that we have added water. Now we have also, taken another liquid that is containing color, food color, like red color we have added over here. And now inside this water, we have added salt so that this solution becomes concentrated, whereas the outside solution is dilute because it doesn't contain any solute in it. So now here we introduce the concept of what is hypertonic and what is hypotonic, right? So what is hypertonic? Hypertonic, the solutions have higher concentrations, than the given solution. So here we introduce the concept of concentrations. We can also ask them what care the doctors are taking when they're giving us intravenous injections or when we are on a drip, right? So the solutions should be isotonic. So now what happens if we, why does the water get inside this potato? You can see there's a pin over here which we have put on the, potato, and the level of water is under the pin before the experiment is done. And after the experiment gets over, you can see that the water has risen, the colored water has got inside the potato membrane. So why has the water got inside? Why has the water got inside? Yes. Yes. Let me know, please, how and why has the water got inside? Right? Osmosis. Absolutely. So that's going to be osmosis. Can you just tell me one condition which is essential for osmosis to take place? Yes, Asha ma'am, I agree with you. Amreen ma'am, high concentration to low concentration. Absolutely right. Absolutely. Absolutely. So there's a semi-permeable membrane which is required. Yes, Vaishnavi. We require a semi-permeable membrane which is going to be permeable only to the solvent molecules and not the solute molecules. So here beautifully we are explaining that the water is a solvent has got inside. Why it has got inside? Because it's moving from the lower concentration of solute to the higher concentration of solute. So tell me, is it going to go on continuously or is it going to stop after some time? Is this process of osmosis going to continue or it is going to stop? It's going to stop, definitely, Diksha ma'am. I agree with you. So under what situation is it going to stop? What do we call that situation? Exactly. We call that at equilibrium. Monica ma'am, I agree with you. Very nice. Such a responsive audience we have here. Now, the simple experiment which children do in the lower classes is indicators, where we can ask the children to make red cabbage paste, which can be used as an indicator. I'll just skip that video. So here we can ask the children, to take red cabbage, chop it down. Yes, Muhammad sir, reverse osmosis, absolutely. So here we have red cabbage chopped down and filtering it and getting the water extract coming out. This is an indicator. So here we are teaching the concept of natural indicators, like we have turmeric as a natural indicator, beetroot as a natural indicator. We have this red cabbage as a natural indicator. And we can ask the children to collect all the different kinds of substances which are available in their household, like milk, vinegar, or you can say acetone, or anything which is liquid. And we can just basically show them that what color change, children, do you find when we add this China rose? Yes, Chitali ma'am, I agree with you. We can have, in the basic, it turns green, Gayatri ma'am, right? Hibiscus also we can use. We can use tap water. Tap water will remain neutral. So uska color hai, it's going to be violet. Similarly, if we add this red cabbage to lemon juice, its color is going to be acidic. So basically, we're going to expose the students to what are natural indicators, what is their use. We're going to use them to test acidic, basic. Asha ma'am, absolutely. Turmeric also. So we will have 3 colors. And now, Anuradha ma'am, right? We can use this chart, which we have in our chemistry laboratories. Shija ma'am, exactly, agree with you. And we can show ki bacho, we can have this, segment. If your substance is highly acidic, its color should turn red. If it is highly basic, its color should be, yellowish, and in intermediate will indicate the various ranges. So this is one of the ways. Also, one of the best ways which I feel that the students should be motivated to join your class and should be, attentive is the music. So just, I just got a beautiful, music for you for acid base. How can we introduce? So just we'll have a small, enjoyable session now.
Acid-basic salts, the increase of some ions
enjoy.
or ionic compounds. It's true.
Yeah, very nice, Radhana.
Increases number of hydrogen and ions when dissolved in water. Thought, oh good lord, this tastes sour, tastes bad, breaks apart, forms ions, conducts electric. Acid basic salts, the increase of some ions or ionic compounds. It's true.
So that was a
Acids
very,
in
I mean, I would just, due to the paucity of time, I'll just go back to my PPT. And this is one of the beautiful ways I'm sure all of you are going to attract your students and, keep them engaged in your classrooms by playing such beautiful, because children have inclination towards music. And after this concept, are you going to start real teaching in the chemistry laboratory where we bring the different chemicals. Now I have got acids commonly used like tomato sauce. We are using bases like soaps. We are using salts. Then we can have the blue litmus paper and start showing them that we start dipping the blue litmus paper and turns red. If it does not turn red, it's not an acid. We can also use phenolphthalein, as we all know that it's going to turn the acid into no color, base into a pinkish color. So, so this is the way we start the activity by introducing the activity, initiating it through a music and then start doing it in the real classrooms. Now, this is something not from chemistry, but we can also start using clay modeling or paper modeling, bamboo tree. This is our students have made it in the school. The bamboo trees, for example, this is coming under the project of Ek Bharat, Shrestha Bharat. As we all know, Maharashtra and Sikkim are paired states. So this is one of the activities our students had done. Then this is animal cell, which the students had done it. It's creative use of colors, how the various organelles like mitochondria, Golgi bodies, and all those are arranged. We can explain them. We can also use quilling work. So here the basic role will be of art and craft teacher who will help a science teacher to, incorporate these things into their teaching. Then we can see the quilling work explaining the photosynthesis and the solar system. Now, Rangoli is used in the right-hand side over here, how beautifully the children have done the work. Please encourage lots of creativity in the minds of students. So here there's a poem for class 10th, Management of Natural Resources. So I'll just read few lines of this poem. The development everyone needs, cause for our country we should not greed. Our responsibility is not to forget, cause afterwards we are the one to regret. Right, Kartika ma'am? Yes. Let's wish for sustainable development goal by playing an important role. Wishing for a place of equality by a bit change in our mentality and requirement for hospitality. So this is what children are making, rhyming words. So their creativity increases. Also, they understand that they need to preserve the environment. Now, these are some of the poems which our students had made, which I just took some clips of it. Yes, Prabha ma'am. On heart, on magnets. This is an experiment from class 11th and 12th where we teach the art of extracting the aromatic compounds called as esters. So what is fragrance? What is perfume? How is perfume extracted? So we can have a small experiment in the chemistry laboratory. So this is relating it with our everyday life. So what is this reaction known as? Can someone tell me what is this reaction depicted in the diagram over here? What is this experiment about? Absolutely, Ganga. I agree with you. That's esterification, and we will be getting fruity smell. And which ester are we going to get in this? Can you tell me which ester, Subhadra ma'am? Rashmi, Vinita, yes. Which ester are we going to get here by using ethanol and acetic acid? Ethyl ethanoate, absolutely. So, you can just ask students and also relate what are the various kinds of esters present in the fruits. Why are fruits so sweet smelling? Why are honeybees and the various insects getting attracted towards fruit? Why are the flies getting attracted towards the fruits? Because they're so sweet. So here we have the various kinds of fruits in the picture. Like we have cinnamon also, which is one of the spices. It also contains an ester, ethyl cinnamate. We have pine having boronil acetate. We have apple, which has butyl acetate. So we have butter. Yeah, it doesn't have ester, but it has acid. We can also, this is from physics now, we are relating music and poetry with class 9th, like sound and force. Children who are beating the drums, they are singing the song also, and they're talking about what is force. Force is a push or pull. Force makes things go up, go up. Force makes things go down, dudum, dudum. And they start, playing the drum. Force make things go back and forth. Force make things go round and round. Force make things go round and round. And they start beating the drums. So this is a very enjoyable activity. Now, this is effects of force and pressure, which we can connect chemistry and physics both. So here we have what is the effect of force and pressure. So the girls over here, you can see they are blowing air through the straws and they are just making beautiful designs. And these colors which they're using, they are natural indicators. Like as you rightly said, Anuradha ma'am, that's blow painting, absolutely correct. So here we are using hibiscus, beetroot, turmeric, red cabbage, all those kinds of indicators. So here we are connecting it. The children develop the interest for the subject, physics and chemistry both. Then we have another art integration activity, art of molding. We can ask them to make statues like during Ganpati festival or any other, occasion you can make. Like this is, this is now gypsum, plaster of Paris, which is calcium sulfate, hemihydrate, which is used by dentists. Yeah, so these are the various molds which the children have made. These are the students, our school students who have made some art and craft work, the children enjoying their art and craft after the school. Now, washing soap is one of the wonderful activities and experiments which children do, and we can also do it in the classroom, in the laboratory. Like what we are using for this experiment is sodium hydroxide, which is a base with water. We're using, we can show that what sodium hydroxide, it's a base. When we add the blue litmus paper, it turns red. We are using coconut oil for this 60 ml. So these are the specifications of that experiment. And we're also using common salt and 200 ml of water. Now, when the experiment starts, we're adding this NaOH to the coconut oil. Just keep it for some time and start warming it up. And now start stirring it and adding the NaCl solution to this mixture. Now, I would like to know from you, what is the name of this reaction, which is in our chemistry? Yes, Anuradha ma'am. So what do we call this reaction which we use to prepare soap? Saponification, exactly. Very good. Excellent, excellent. So in saponification, let me know, why are we adding NaCl over here? Why are we adding NaCl? Satya, Nisha, yes. Is it Ajisha? Why are we adding? Yes, salting out. We are wanting to shift the reaction equilibrium to the right-hand side to precipitate it for solidifying. Shrija, yes, Shrija, very good. So this is what we are doing. And when we add NaCl solution to this mixture, we just keep it for some around 30 to 40 minutes and it solidifies. We remove the supernatant solution and let it dry, and we have absolutely handmade, homemade soap cake ready. So everybody, even when I was a child, I had made soap at my home. I think I was in class 7th at that time, and I had developed lots of interest towards experimenting. And now we come to the art integration of it. So that was an experimental side. Now art integration, we can start teaching them children how to paint using turmeric, which is an indicator, and soap, which is a base. So the indicator will be turning into red color, and see beautifully the drawings can be created. Look at this. So we can have a turmeric painting competition organized one day in the class. Now this is wall hanging is one of the art integration activities I picked up from one of the YouTube videos only. Here we are trying to teach the students how to compare between lanthanoids and actinoids. We can teach them, or we can have the properties of the D block elements and the reason for that. Like for example, on the left hand side, we can see high ionization enthalpy. As we all are aware that in the board exam, lots of give reason questions and 1 mark questions are asked in the D and F block elements. So the children find it a little boring to learn this concept. So here on the LHS, we have the question, and on the RHS, we have the reason for that. Like high ionization enthalpy, because they are very small size, very high nuclear charge. Why are they paramagnetic? Lots of unpaired electrons. So, this way, and these wall hangings, you can use it for decorating your chemistry laboratories. Yes, song is, yeah, Prabha ma'am. Yes, that's right. The beautiful concept of hybridization, what is intermixing of orbitals to create, new set of orbitals called as hybrid orbitals. Here, look at this beautiful work. We have the 2 balloons here, SP. We have 3 balloons here, SP2. We have 4 balloons here, SP3. We have, now here we are teaching the concept of lone pair and the bond pair. So like this, we can introduce the concept of what is bond pair, which is used for making bonds, and what's lone pair, which is not involved in the bonding. Yes, we can use colorful balls also instead of balloons. Absolutely, Anuradha ma'am. Absolutely. Also, we can start teaching them the drawing concept by mixing 2 or 3 colors and show that when I mix, let's say, yellow and blue, I get a green color. And this is how the hybrid orbitals are also formed by mixing, like S and P. When they are mixed, we will get 2 sets of orbitals with 50% S character and 50% P character. Yes, of course, I forgot that we can do block printing and various designs can be created. That also can be done. We can ask the children to look around in the Anuradha ma'am. Yes, absolutely. We can ask the children to look around and see the various types of objects which are around them. Like a ball is there, so it looks like a spherical shape, so it's an S orbital. A dumbbell which we are using for exercise, so it's going to be a P. We can say P-shaped orbital. We can have people leaves or something like that for a P-shaped orbitals. So we can ask the children, we can have a Rangoli making competition on one of these days, and they can draw the various molecules which they have learned. They can also draw the orbitals, the d orbitals, the 5 sets of d orbitals, the T2g and the EG sets of orbitals, because children often get confused between what are triply degenerate and the doubly degenerate orbitals. Then we have, yes, I have a question for you now. This beautiful Rangoli, which molecule is this? Let's see who's the person who answers this fast. This is from the chapter. Yeah, we can use flowers also, Prabha ma'am. Yes, absolutely. So this is from the chapter biomolecules. It's a glucose, Nimita. Absolutely good. Absolutely good. So this is alpha G glucose. And now we have one of the principles of chemistry over here, Faba. Faba, we have one of the principles, Samuel. Absolutely. So can you just tell me which principle are we talking about when we draw? Aufbau's, absolutely. Diksha, fantastic. So this is Aufbau's principle, which talks about that orbitals will be filled in the increasing order of their energy. So here the children love to draw Rangoli. Muhammad sir, yes, absolutely. And they will like it also. Then the chapter, yes, absolutely. The chapter coordination chemistry also can be taught via Rangoli. Metallurgy also, now here you can see we have drawn a basic process, froth flotation process for the concentration. So you can ask them to draw Rangoli. Also, you can have storytelling competition here, that how this froth flotation came into existence, Anuradha ma'am. We can teach them that one of the washerwomen was one day washing her clothes and she accidentally came to know about this method. So like that, we can, explain them this concept. Then this is a beautiful skit on a science skit on periodic table, which we are going to see. I'll just show you that. Yeah, this is a wonderful skit, which I'll just skip actually.
Hello everyone, this is child is fighting with me. He's telling me that he's the greatest element.
Oh, is that so? Come. Hey, Gold, come out.
What's the matter, Oxygen?
Your son is quarreling with my daughter on who is better.
Why are you two guys fighting? Don't be so toxic.
Sulfur, we non-metals are the greatest, right?
Yes, we are, of course.
Good joke, but we are everywhere, from the body of living organisms to the structures they create. Haha, bad joke. You guys are everywhere, but those living organisms need us to live. We are the greatest. We are the greatest. We are the greatest.
Hello, everyone. I am Silicon. You are Silicon, a non-metal, right? Come on, let's fight against those metals. No, you're a metal. Come join us. No, I'm neither a metal nor a non-metal. I have properties of both metals and non-metals.
So here, I'm sure you will enjoy this skit, and such skits can be organized in our schools also, where children will develop lots of understanding about what are metals, what are non-metals, and there are some elements which belong to both the categories, and we can introduce the concept of metalloids. And this is fantastic, actually. So I'll just skip this part, and I'm sure you will understand and enjoy that. Now, this is another art integration activity which we can ask the students to do, making a documentary on any topic, especially from environmental chemistry topics from class 11th. Now, this can be from class 12th also. Now, this is, class 12th, we can talk about rusting process, and class 11th, we can talk about environmental chemistry. So here, like iron pillar of Delhi, right? So here, why is this pillar not getting rusted? Because it has got a coating of iron 3 hydrogen phosphate hydrate on it, which has got high phosphorus content. So why is the iron pillar not rusting? Because of the excessive phosphorus present in it. Now here we can also relate, okay, I'll just skip that video. We can also ask the students to, understand about marble cancer, which our Taj Mahal is facing. Why is Taj Mahal turning yellow? And it's, so we can just ask them to prepare a documentary on it. Like the marbles which we are using to, we have used to make the Taj Mahal contains iron. And iron, of course, eventually is going to get reacted with oxygen and starts turning into little yellowish color, reddish color. And now acid attack takes place, so its color is changing to yellow. So we can talk about what is marble cancer. It's a phenomenon of corrosion of marble by acid rain and pollutants, resulting in corrosion from white to yellowish appearance. So here we sensitize the children. Yeah, we can relate with the marble flooring also, Narada ma'am. You're absolutely right. So here we sensitize the children towards, preserving our national heritage. Also about avoiding the pollution. We talk about chemistry here. What is corrosion? So it's a phenomenon of any metal or, non-metal getting oxidized. Lower class children, we can teach them the concept of compounds by ionic jigsaw. Like for example, let's take this ammonium. It has got one group, so its valency, it can just combine with one. It's a univalent ion, so it has got just one group. Chloride is also univalent, so it has got also one edge over here. So we can interlock them. Magnesium is bivalent, so we can just have them with the two groups like this, and oxide with again two. So, in this way, we can create the concept of valency and how the ionic compounds can be formed. Same way, we can have valency. Yes, Vaishnavi ma'am, I agree with you. We can introduce the concept of valency. As many valency, they will have those many, open ends can be created. And this is quite an engaging activity. And these cards, you can preserve them in your laboratory and use it for the next year also. Now this introducing the concept of ionic bond, how are ions formed, what is a metal, what is a non-metal. So metal is the donor of electron, the non-metal is an acceptor of electrons. We can introduce that concept. Again, we can introduce that with the help of role play. So I'll just, play a small clip of what is role play in the case of sodium chloride. How is sodium chloride? Yes, friendship also.
Hi, I am sodium. I am so unstable. I feel so suffocated under the kerosene. I can't even breathe. If I come out, I will catch fire. Someone please help me.
I'm chlorine. I'm so unstable and reactive. So people use me to
disinfect swimming pool and drinking water. They're so scared of me because I'm toxic and corrosive. Someone please save me. Suddenly, both of them meet each other and discuss about each other's problems. They realize that both of them are unstable because both want to achieve octet either by gaining or losing an electron. They decide to form a bond and become stable. Suddenly, their transformation results in a new compound, NaCl.
Hi, I am NaCl, sodium chloride, and I am in compound. I am very happy because I am.
Yes, so that was one of the beautiful activity which we can use to introduce the concept of what are metals again. Why is a metal unstable? Because it is needing to donate that electron and achieve octet. Chlorine again is unstable. It wants to accept the electrons. So both of them, when they combine together, they achieve stability because the energy is released. So all the high energy atoms will be unstable. Now, this is culinary art. While cooking in the kitchen, a mother can teach. Also, a teacher in chemistry lab also can teach the concept of what is melting point over here. We are heating salt and sugar on both the borosil containers and seeing what is the melting point, which one melts faster. You know, can you just tell me what is the maximum temperature a Bunsen burner can give us? Anybody from the group can just please tell me what is the maximum temperature a Bunsen burner can give us, friends? Around approximately how many degrees Celsius can we achieve by Bunsen burner? Exactly, Anuradha ma'am, so good. It's 1500 degrees Celsius is the maximum temperature which we can achieve. So here we can introduce that absolutely. That 186 degrees Celsius will be the bonding in the case of, let's say, sugar, and 800.7 degrees Celsius for NaCl. Why is the melting point higher? Because it has got strong bonds. Why is the melting point lower? Because it has got weaker hydrogen bonds. So now here we introduce the concept of Bunsen burner also. What is Bunsen burner? Take them to the laboratory. Basically, this is for lower classes as well as for class 11th, because many students in class 12th also do not know how to operate a burner and what are the safety measures which we have to take in a burner. So we can introduce the concept of the various parts of burner in this manner. The luminous flame and the non-luminous flame. What position of the gas knob indicates that it is switched off. So right now it is perpendicular to the pipe, so it is switched off. A luminous flame will be yellowish in color because it's from the incomplete combustion of the fuel. Then we talk about the non-luminous flame, which is very hot and it's blue in color. In this way we can introduce, and now we integrate art into it by introducing them to the diagram and asking them to label the various parts of the burner. So this is how we can relate it. We can now connect the two subjects like mathematics and science. Mathematical concept of Venn diagram comes into existence, and we can connect any two topics. Like here we have taken a collage of ionic and covalent compounds. So what are the similarities and the differences between these two? You can very well exhibit by using the Venn diagrams. Diamond and graphite, what are the similarities? They are both of carbon. What is the dissimilarity? Diamond is very hard and graphite is quite soft. The similarity between metals and non-metals, Anuradha ma'am, absolutely. Solid, liquid, and gases, exactly. We can use this. Can you just tell me for which other concepts can you use Venn diagram? What other concepts can we use the Venn diagram for? One of it, Anuradha ma'am has already said we can use it for solid, liquid, and gases. What else can we use it for? Bonding, yes. Acid, bases, cellulose, and starch. Absolutely, that's a fantastic. Cellulose and starch, we can use it. Like starch will be having alpha glucose, lanthanoids, actinoids. Absolutely. Please go ahead and start making Venn diagrams for these concepts because children really find it very boring and to learn. Ores and minerals, of course, we can use this. Solutions, yes. We can use it for, I think, azeotropies or Raoult's law, positive deviation, negative deviation, coal, petroleum, natural gas. Absolutely, absolutely. Very good. Thank you so much for your wonderful answers. Now here we come to an interesting activity, crafting and baking. We can ask students to design their own cups, design their own designs, and to the photographer shop they can go and get these cups designed for them, their birthdays. We can also celebrate our birthdays. Now this is the cake which our team had made on the birthday, and you can see various elements because we love chemistry. Oh yeah, let's not miss the bio cake where we have drawn. Can you tell me which cell is this? On the left hand side cake, which type of cell is being shown in the cake? Absolutely, Faba, fantastic. It's an animal cell. Now come to Diwali. Now we can relate it with the art, art with the culture, the subject with the culture. We can explain that during Diwali we are using sparklers, fuljhadis, that is, and all the beautiful colors, are coming due to the reactions of metals like strontium, barium, and calcium, and so on. So now here the teacher explains the concept of flame test. Now this is the wonderful thing which is mind maps, and I'm sure this I've taken from my teacher's lesson plans, like how make mind maps of various topics and make it really interesting. I'll just take you to like chemical equations we can have. Right, Anuradha ma'am. These mind maps are the best. Yeah, see, now chemical reactions and equations, like for example, you're starting. So this is from class 10th, where you can make mind map. What are chemical reactions? What is a chemical equation? What are the types of reactions? Yes, Diksha. Yes, absolutely. This is very important. Last minute revision if you want to do. We are going to make mind maps. Carbon and compounds, such a good topic. You can start teaching this in class 10th. Right? Absolutely. For every topic, we must have mind maps. Diagrams, of course, they are the integral part of chemistry and physics and biology also, Prabha. And we can like, which diagram is on the left hand side? Can somebody tell me which type of cell is being depicted in the left hand side? The Apollo Space Research Program, this cell was being used, right? Absolutely, Vinay. That's the fuel cell where we are using hydrogen and oxygen, where hydrogen is acting as a fuel and it's an incomplete combustion to give us electricity. It was used by astronauts in the Apollo research program for the first time. Now, again, the craft work, we can ask the students to make the balls and beads they can use to explain what is solid state. So you'll have compact packing, liquids will have a little difference between them, gases will be very far away. The intermolecular bonding will be very strong in the case of solids and very weak in the case of gases. And we can use ball and stick, something like this, so every, this, I think, broom ka lakdi, that is jhadu ka lakdi, they have used. Anuradha ma'am's biology also you can use, and physics also, absolutely. Periodic table, this is for the small kids like class 6th, 7th, where they are being introduced to periodic table and the elements. You can ask them to stick various things whichever they feel, and write the element what is present. For example, if you see there is iron, so they have stuck an iron object. Copper coins they have stuck. They have used silver ka kuch they have attached, aluminum foil. So you can relate it with everyday life, and they really enjoy this. Now, this is mind maps for class connective. Yes, absolutely. This is mind maps for the class 11th classification of elements and periodicity and properties. Now, what we do is we just start reading a paragraph of the textbook and start creating the mind maps between different terms. Like, for example, we start with elements. So, elements were first classified by Dobereiner, and he gave triads. Then we have the second classification by who gave Newland, who was given Newland's law of octaves. Then we talk about elements were again classified thirdly by Mendeleev, and he gave a periodic table. Now we have made two concept maps, and now we are going to join them up. And when we join them up, we get a third concept, a bigger concept map. So this is how we start creating by reading every topic or every paragraph. We can start creating a mind map, and I'll just show you. See. This is how we are going to a bigger version of the concept mapping. This is how we are making it and making bigger and bigger. See, we have introduced the concept of metals. Like, for example, we have elements which can be metals. Their oxides are basic. Then non-metals, their oxides are acidic. Now we have metalloids, which are between metals and non-metals, which are found on the border between metals and the non-metals. Metals are elements which are found on the left side of the periodic table and in the center of the periodic table. Non-metals are found on the right-hand side of the periodic table. Okay, then what happens to the atomic size? It increases down a group. What happens to atomic size when you across a period? So it decreases on moving from left to right. So, this is the way I'm sure you all must be doing this. So this kind of concept mapping can be done. And when the whole thing we combine it, see, such a beautiful chart has come up. This can be stuck on the study table or somewhere, and the students can revise the entire concept of what is modern periodic table. Okay, just over here, we have a beautiful a song on periodic table, which I'm sure you might have heard it. We'll just hear the initial lyrics of it.
And now, ASAP Science presents the Elements Arctic Table.
There's hydrogen and helium, lithium, beryllium, boron, carbon everywhere, nitrogen all through the air, with oxygen so you can breathe, and fluorine for your pretty teeth, neon to light up the signs, sodium for salty times,
Magnesium,
aluminium, silicon,
phosphorus,
then sulfur, chlorine, and argon,
potassium,
and
So
calcium
this
so
is
you'll grow
how
strong.
the entire
Scandium.
periodic table has been created in a very beautiful rap song. So the children, even as small kids listen to the poems and the songs, they remember it. So this is the way we can play this, and the children will remember it and they'll enjoy it. Then we have this Bala method also, which we can use. Can we? What is the meaning of Bala method? Can someone tell me what is Bala method? Yes. Okay, so Bala method basically would be absolute Chandra Mahuri. So building as a learning aid, Nirmala man, fantastic, such a beautiful thing you've talked. It's the whole infrastructure of our school, Anuradha ma'am. Yes, we can use the building as a learning aid. We can draw beautiful drawings and pictures where students will develop. So this is periodic table in the chemistry lab. Then physics lab, you can have something related with physics. For example, you can depict various topics, like for example, energy stores and all that. See, right? So this is how we can use the Bala method. I will just take you to my pre-primary school and show you how we have used Bala method for pre-primary wing. Forward it. So that was such a beautiful recording we had done it today itself, because I wanted to just share it with you. And I've taken these various slides from internet also, Royal Society of Chemistry. So I'm thankful for all of that. Thank you so much, everyone. So, any questions? You may just put it in the chat box, please. Stop sharing. Fine. All right. So thank you so much.
If there is any question, they can raise their hands and Najia ma'am can, take it up.
Thank you so much, everyone. And I would like to hear from you. If you have any queries, please just can just let us know. And I'm sure you're going to use some of the parts of this video and make the lesson very interesting for your children. Ultimately, the goal of our education is that the child should be happy. It should be happy learning.
I think we're getting a good feedback, ma'am.
Thank you so much, ma'am. And it was really a wonderful audience with such an intelligent audience had joined today, and they were answering the questions so beautifully.
If anybody has any question, they can put it in the chat box or they can raise their hands. If anybody want to contribute also, sharing their experience.
Yes, if you have any good suggestions, please do give, like how we can integrate art and chemistry. There are various topics, which we can design our own innovative methods. Thank you so much, everyone.
Yes, Najia ma'am, please go winding up.
Yes, I think you covered all of it. We would like to extend a heartfelt gratitude to Miss Kavita for sharing her invaluable insights, your expertise, not only telling us the different forms of art, you gave us the examples, the concepts that go along with it. Thank you for your time, your dedication, and providing us the practical strategies. We look forward to implementing it in our everyday professional growth. Thank you once again, ma'am.
Thank you, ma'am.
Welcome, dear
Thank you so much, ma'am.
You're most welcome. Dear participants, kindly note the link for certificate and feedback form has been posted. You are requested to fill up the form with all the necessary details. I, Najia Amin, on behalf of Extra Mile, would like to extend a heartfelt thanks once again to Miss Kavita for your gracious presence and enriching experiences that you provided. We are grateful to Dr. Abdul Salam for his generous support and invaluable guidance. Most importantly, I want to express our gratitude to all our participants for their enthusiasm and active involvement. I sincerely hope this session has been both fruitful and enjoyable for everyone. Thank you.
Thank you, ma'am.
Over to you, sir.
Yeah, thank you. Well, a wonderful journey it was. Thank you so much, Kavita ma'am. Lot of research has gone into, and you have spent a lot of time into it, and definitely that has helped the participants who have joined a lot. So we don't know how Extra Mile should thank you. We are very grateful because lessons in subjects like chemistry, physics, and all very we get very rarely, and you have tried to give the best. That is the highlight of the program, the session. The best we got, and not only art integration, but lots of experiments and how these experiments can be connected with different subjects, multidisciplinary approach, and cultural diversity, how it can be brought together. All these were, embedded in the session. Thank you so much. Though we waited for some time for your session,
yes,
it proved to be very, very useful and very beneficial. So thank you so much.
Sir.
Keep connected. Keep helping
yes,
us,
sir.
science teachers, chemistry teachers, with your
Definitely.
expertise and knowledge and wisdom. So thank you so much, Najia ma'am, for your help. Wonderfully, you have coordinated with Kavita ma'am and all the participants who have joined. Please stay connected. Let us use these ideas
Platform, definitely, sir.
in the classroom so that chemistry will be a very interesting subject when it is connected with art and other disciplines. So thank you so much once again, everybody. Keep connected. Have a very good night. Thank you.
Thank you, sir. Thank you. I thank the organizers, Biju sir, Salam sir. You have been doing a great work, and tirelessly you have been working and following up also. So commendable. I just hats off to you. Thank you so much, sir.
Thank you. Thank you. We have met
Yes, sir.
only
Thank you,
through
sir.
that B-type platform.
Yes, exactly,
Thank you.
sir. Exactly.
All right, man. Thank you. Thank you, everybody. Good night. Good night, everybody.
Thank you,
Good night,
sir.
sir. Good night.